Oh, this is Distinti's World, S009, the secrets of Tesla finally revealed. I did not want to spend time on a video of this nature. However, I get many people sending me links to the one we are about to discuss. By educating you, I hope to better enable you to help me. And here's the most recent link down here. The name of the video is Vortex-Based Mathematics, the most profound rediscovery of all time. Make it viral. I don't know how you can profound rediscover. So basically what you got is you got some yahoos that have some fancy graphics and videos, and they go over all kinds of gibberish and say, oh, 1 plus 2 is 3 plus 4 divided by 10, and that's 8, but I'll get into that later, and if you just watch the video, that's all it pretty much is. And then somewhere along the way, they show you a magic trick. And they go, oh, if we just hook up to the 12-volt battery, we're only able to light 8 LEDs. But then when they put it through their unification coil, they're able to light 98 LEDs. And I've seen a lot of videos like that. There's one guy that, says, well, with a 12-volt battery, it can't light a 40-watt light bulb, but after my generator, and he's got basically, looks like just like a dynamo, he can light the 40-watt light bulb. And his friend does a voltage measurement and says, yeah, we got more voltage out than we got in, and they think they've got over unity. So I'm going to show you how the magic trick is done. And let's go to that video now. Okay, what we have here is the Tesla technology generator. Over here, it's being run by, the input is essentially a 12-volt battery. This is a battery simulator. It gives 13.8 volts DC at 10 amps. Okay, and the purpose of this box is to be able to develop battery-operated, cigarette-lighter devices without having to go out and run around by batteries every day. So that's the purpose of this box. So it's basically a battery simulator. And it also gives you regular outputs over here for taking the voltage off on the side. And I've got that wired into a standard outlet so we can check out if it'll drive a 40-watt light bulb. So let's here's the leads for the 40-watt light bulb. We will plug them into the standard 12-volt output, and we will see that the light bulb does not glow. There's not enough power to drive the light bulb. So what we're going to do is, with our trusty rusty amp meter, we're going to see how much current is being drawn. And we see it's about 120 milliamps is what we see as the current being drawn by the light bulb. Okay, but now what we're going to do is, what I have on the other side of the Tesla technology generator is I've got it wired into a standard outlet so that I can take the light bulb off the battery side and plug it into the output of the generator. And voila, the light bulb glows. And let's see how much current the light bulb is drawing. Oh, I got to change it to AC here. This is AC. On the AC side, look at that. We're drawing 440 milliamps this time. Wow, it looks like we got more power out than we got going in. And you say, well, what is this magic Tesla generator that everybody seems to be demonstrating? Well, my friends, it is simply just a power inverter. There's a lot of different ways to make a power converter. This takes low current or high current, low voltage, and converts it into low current, high voltage. Again, it takes high current, low voltage, converts it into low current, high voltage. Now let's see, now that this is on and we've demonstrated that 440 milliamps is being drawn by the light bulb, let's see how much current the actual converter is drawing itself. What we're going to do is switch back to DC. And I got to zero it. And we're going to clip it over here. And we see, look at that, it is drawing 286 milliamps is what it's drawing. Drawing 286 milliamps in order to supply, I got to go back to AC, about 370 milliamps on the other side. So as you can see, when we hook the light bulb straight up, so That's all it is. A lot of people, they have different things here. I've seen people have little dynamos, or dynamos basically a generator run by a motor. I've seen a whole bunch of kick-up coils. I've seen all kinds of stuff. That's basically what this runs on. This runs on a kick-up coil technology, which basically is something that can be traced back to Tesla. So they're not lying when they say it's Tesla technology, but it's not something fancy. It's not something that's not already in widespread use. All you're doing is you're matching the power to the load. Okay, and we'll do the calculations on pen and paper in the next part of the video. So we're drawing 12 volts at 2.8 amps over here, and we're driving the light bulb with about 400 milliamps at about 115 volts. And so we'll do the calculations, and you're going to see that there's more power going into this than there is coming out when you do the proper calculations. This is not free energy over unity. So this is the demonstration, end of the demonstration phase. Thank you. Okay, coming back, let's do the math. When we attach to the 12 volt source, which really I went back and measured it, my voltage source produces 14.2 volts. I had to do that, and I'll explain why in a second. The bulb did not light, however, it did draw power. So 14.2 times 1.4 milliamps, or sorry, 140 milliamps is 2 watts. Not enough to make the filament of the bulb white hot and make it glow. But when we attach to the power converter, the light bulb lit, but it did lit dimly. I had to go out back and remeasure the voltage, because if I assumed it was 115 volts times 44 amps, I got like over 50 watts, which would have meant more power out than power in, and these people were right, but no. The output was only at about 75 volts RMS when you put it through a proper RMS meter. These power converters that you get off the shelf don't really have pure sine waves, so you have to get a true RMS voltmeter to find the true RMS voltage out. And so you take that, multiply it by the 0.44 amps, and we got 33 watts of power being delivered to the bulb, which makes sense because the bulb isn't lighting up as bright as it normally would be for a 40-watt light bulb. And then we measure the input, was 14.2 volts at 2.86 amps. I know I said 286 milliamps early in the video, but later I corrected and said it's 2.86 amps. It is 2.86 amps. And I went back out and double-checked it just to make sure. Sometimes I get my mouth doesn't connect with my brain right. And if you do the calculations, 14.2 volts times 2.86 amps, you get 40 watts. And so what we're seeing is the power coming out of the power converter, or inverter, depending on how you want to say it, it's giving you 40 watts out. I'm sorry, 40 watts in for 33 watts out, which makes sense because you're going to get some loss in the conversion process. And so you have less power out than you have power in, and things are as expected. We're not violating the laws of physics. We haven't discovered anything new, and we're getting the same results that they get. Now, if we do the same calculations for LEDs, now I'm assuming here a normal power converter because I made this slide first. Okay, if you take a 12-volt battery, and see, a red LED takes about 1.4 volts to turn on. So if you put all your LEDs in series, and you try to drive them with 12 volts divided by 1.4, you're only going to get about 8 LEDs to turn on in series for a 12-volt source. But since 110 volt AC, let's say you have a good power converter that really does give you 110 volts AC out, but that you have to convert to peak. This is 110 volts RMS. You could convert it to peak, which is about 150 volts peak. So you take about 150 volts peak and divide by 1.4 volts per LED, you get about 100 LEDs in series that can turn on. And that matches what these people were claiming before, but it means that a normal power converter produces more voltage output than theirs, and it uses standard theory, not unification coils. It uses regular kick-up type coils like this. So don't be taken by gibberish. There are many videos out there, including Discovery Channel specials, all claiming outrageous things, speaking all kinds of fancy words, showing all kinds of fancy pictures, but none of that matters. Don't accept any of the fancy words that sound intimidating. Don't accept any of the fancy pictures. Ask yourself this question. This is the only question that matters. What have they done to improve human existence, or my life? What have they done to improve your life? Remember, that's the fourth rule of acquisition, utility imperative. It doesn't matter if you call something a toroidal vortex math. It doesn't matter if you call it ether. It doesn't matter if you call it quantum flux. It doesn't matter. if you call it dark energy. It doesn't matter. The point is, what has this stuff done to make my life better? Because you can call it anything you want. It rose by any other name. So don't be taken by the fancy words, the fancy gibberish, the fancy pictures, the fancy animations. Is what real thing is produced. Something that you could possibly even mimic in a home experiment to show that there is something there. What do they call it? Doesn't matter. As long as there's something there that's useful, whatever you call it is irrelevant. Okay? As long as you can produce something that'll put food on your table, will heat your home, put money in your bank, that's the only thing that matters. Nothing else matters. Everything else is gibberish. So just understand, utility is the most important thing that we can get out of science. Fancy names, fancy words, all that stuff is gibberish. So if you want to help me out, send me links to experiments that show something new and interesting, and I'm going to show you an example of a link I'm meaning to get back to once I get the high voltage stuff going. And let me show you where we are with high voltage. This is the 12 kilovolt source. I'm embedding it. It's basically, I'm going to show you, I hope I get it lined up with the camera. It's basically just a capacitor diode thing. You've probably seen these circuits all over the internet. This one will do 12 kilovolts. And the only thing I've done differently than other people is I'm encasing it in PVC for safety reasons and to prevent arcing and corona discharge. And I've separated, at the 6 kilovolt mark, I put a insulative disc in here to separate the two halves so they won't be arcing between the two halves. Hopefully to keep the arcing down. I might have to separate it at different strata. The next step now is to get the Arduino to control the driver coil and develop the driver coil circuit, which will be driven from the 170 volt power source that I showed you last time. So that's where we are with the high voltage stuff. Let you know the progress is happening. Okay, thank you very much.